Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A principle of modern cosmology is that so-called space-time is a physically real entity. In Albert Einstein's theory of general relativity, light will follow the so-called curvature of space-time. For decades, astronomers have claimed to observe the bending of light passing around massive objects, an effect called gravitational lensing. However, as is so often the case in the space sciences, the line between fact and interpretation is routinely blurred. Today, Thunderbolts contributor Andy Hall discusses the tenability of gravitational lensing and explores the growing body of research into its theoretical alternatives.
Einstein's theory of general relativity is the backbone of mainstream cosmology. Anyone exploring electric universe theory must confront the issue of the general relativity model, because in spite of the fact it doesn't really describe much that we see in space, it is still widely believed by mainstream institutional science. And we are consistently told by mainstream science that general relativity is proven by direct observations. One of those observations, and the first used to confirm Einstein's theory, is an effect he predicted himself called gravitational lensing. Einstein predicted that light should bend slightly as it passes through the warped space-time of a massive body like a star. And this bending or lensing effect should be observed if one could see distant starlight passing through the gravitational influence of a closer massive body like the Sun. Well, in 1919, Sir Arthur Eddington famously made this observation during a total eclipse of the Sun on the African island of Principe. He observed light from distant stars bending through the gravitational influence of the Sun, and on that basis declared Einstein's theory to be verified. Of course, the lensing effect has been observed many times since, as the powerful telescopes of our modern observatories see the light of distant galaxies bend around the galaxies in the foreground. It's quite common, and it's taken for granted the effect is caused by Einstein's theory of gravitation. But for a direct observation to be held as proof requires it to be a phenomenon that can be only explained by that theory, a unique solution, in other words. As I followed my own path of discovery in the electric universe, it was essential to find a classical physics explanation for lensing. Otherwise, how could I accept that general relativity can be disputed? So I discovered the work of Dr. R.C. Gupta at the Institute of Engineering and Technology in Lucknow, India, and wrote about it in the Thunderblog article, Lensing by Refraction, Not Gravity, to bring it to the attention of our readers. Dr. Gupta's paper, entitled Bending of Light Near a Star and Gravitational Red-Blue Shift, Alternative Explanation Based on Refraction of Light, asserts that the theory behind gravitational lensing is wrong, and that the lensing effect is actually caused by refraction through the atmospheres of stars and galaxies. Dr. Gupta shows that if you make certain assumptions about the density of a stellar atmosphere, mathematically, the equation Einstein derived from general relativity to calculate gravitational lensing can also be derived from the classical equations for refraction. Dr. Gupta shows mathematically they are equivalent, but the physics behind them is quite different. Refraction is classical optical physics. Refraction occurs when light waves pass through matter with different densities, and it causes the light path to bend. We see this effect every day. When we see a pole in a pool of water, the pole appears bent because the light is refracted as it passes from the water to the air. We use refraction to bend and refocus light in magnifying glasses, eyeglasses, and telescope lenses by passing light through the curved surfaces of a crystal. Anyone who takes a first-year physics course learns that refraction is an inevitable consequence when light passes from a medium of one density to a medium of another density. It is the kind of simple answer based on classical physics that electric universe theory rigorously requires. The concept of refractive lensing has also been discussed in Thunderbolts forums before. Dr. Edward Dowdy, Jr., a physicist and laser optics engineer formerly with the NASA Goddard Space Center, presented at the EU 2012 conference observations he made of solar lensing at varying altitudes above the photosphere of the Sun. And he showed that the lensing effect varies as predicted by refraction through an atmospheric gradient, not as predicted by gravitation. In another observation, he points to the lack of gravitational lensing observed in the stars that rapidly orbit the Milky Way's galactic center. Big Bang theory predicts there is a massive black hole at the center of the Milky Way, at the location known as Sagittarius A. Astronomers have observed stars in fast elliptical orbits around the galactic center for over a year, some having completed entire orbits. Dr. Dowdy points out that light from these stars should lens if there is a black hole there, as predicted by general relativity. The light should distort as the stars orbit close to the immense gravitational field of the purported black hole. But they don't exhibit any optical distortion at all. This is completely at odds with the predictions of general relativity, but mainstream cosmologists blithely ignore this inconvenient truth. Dr. Gupta points to another optical effect as proof that lensing is caused by refraction and not gravity. Diffraction is a natural consequence of refractive lensing. As light refracts, its wavelengths or colors spread slightly, as happens when light passes through a prism. General relativity predicts no prismatic diffraction with gravitational lensing, since gravity warps space-time is supposed to bend all wavelengths equally. Well, there is a special case of lensing called the Einstein ring. It occurs when the focal point of distant light is directed at the observer in such a way that it creates a complete ring of light around the intervening galaxy. You can see the same effect when a full moon shines through high thin clouds and creates a ring around the moon. This is refraction of the moonlight through the ice crystals in the clouds. This type of ring can be seen around galaxies too, when another bright galaxy shines from directly behind the other. It's called an Einstein ring. Einstein rings are always blue, and mainstream cosmology has never been able to explain why they are blue if they are caused by gravitational lensing. The blue color is an indication of diffraction due to chromatic aberration, the prism effect, which is a predicted consequence of refractive lensing. Dr. Gupta's paper also goes on to postulate that gravitational attraction is only between material bodies, bodies with mass, and that light waves have no rest mass, so cannot be affected by gravity. This agrees with EU theory and refutes another pillar of Big Bang cosmology, the phenomena of redshift. Astronomers see the light of distant galaxies as redshifted, its wavelength stretched, in other words, and attribute the effect to gravity in the expansion of the universe. Big Bang theory actually predicts three types of redshift. First, there is gravitational redshift caused by the pull of gravity on the light, which increases its wavelength as it leaves the gravitational influence of the galaxy it comes from. Then there is Doppler redshift caused by the galaxy moving away from us in an expanding universe, causing the wavelength of the light to stretch the same way the sound of a train whistle drops in tone as it races away, causing its wavelength to stretch. Finally, they also predict the light wave is stretched by the stretching of space itself because the universe is expanding. This is called cosmological redshift. The refraction theory simply says none of these convoluted explanations are true. The physics of refraction says that the wavelength of light is stretched, redshifted, because the speed of light is slowed as it passes through a denser medium. This is because the speed of light is not a constant, it's a speed limit. Light can be slowed down. Light can be slowed in the laboratory by passing it through various mediums. So according to refraction theory, the speed of light is slowed by a medium as it passes into, and hence the light waves pile up like a traffic jam, decreasing the wavelength and causing a blue shift. And when light leaves a denser medium, like a galaxy, into the near zero density of intergalactic space, it speeds up, stretching the wavelength into the red. And this explains redshift, again, with known classical physics. Refraction theory really presents two alternative explanations for phenomena commonly used as proof of general relativity, lensing and redshift. As Wal Thornhill explains in Towards a Real Cosmology in the 21st Century, the electric universe theorizes neutrinos form the ether and provide the mechanical substrate of the universe. Neutrinos have mass, albeit very small, and envelop stars and galaxies in a density gradient. In addition, we know stars and galaxies are plasma entities themselves and are enveloped in plasma atmospheres. At the time Einstein developed the theory of general relativity, the pervasiveness of plasma atmospheres around stars and galaxies was not known, nor had neutrinos been observed. It was thought there was no medium to cause refraction in the vacuum of space. Now we know about the plasma environments of stars and galaxies. We know neutrinos pervade space. It is inconceivable, in accordance with the classical physics of light and optics, that light passing through a medium does not experience refraction. Nevertheless, gravitational lensing is used by the mainstream to study the presence of dark matter and galactic clusters. Redshift is used to calculate the size of the universe and the rate of its expansion. These are all concepts based on flawed assumptions that waste everyone's time. Refraction is the actual cause of lensing, and it needs to be recognized that it refutes two of the major false assumptions behind Big Bang cosmology, redshift and gravitational lensing. It also points to the malleability of mathematics to describe anything. Just because an equation can be made to work isn't proof of anything unless the physics behind the equation is correct. I think the biggest irony of this story is the fact that Sir Eddington claimed he observed proof of gravitational lensing using telescopes that work by refraction. Apparently, he never stopped to think about that.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.